Okay, Ms. Whitaker here, and I want to go over the notes for 11-3, which is solving equations when we have variables on both sides. Now we have, over the last couple of years, we've talked about solving one-step equations where we're trying to isolate the variable, and we're going to keep doing that. The goal is still to isolate our variable, but we've gone through multiple steps where we had to take care of any adding or subtracting first, and then take care of any multiplying or dividing. But this time we're going to be doing something similar to it. The only thing that's different for these problems will be that we have variables on both sides of the equal sign. So we're going to have an extra step of moving our variables over to one side. So these are the problems that we're going to be looking at. Let's look at these examples here on the reteach notes. We do want to take note of what it says right here. It says if possible, and that's usually the case. We want to put the variables on the side where the coefficient will be positive, and that coefficient is a word that we've learned recently. That coefficient is the number that comes right before the variable. And so if we want a positive coefficient, that's going to help us decide which side we're going to move the variable to. Now we don't have to do that. It just makes things a little bit easier, because if you don't, then you're going to have to take care of that negative somewhere down the road. So to keep us from having to add that extra step, if we can make the coefficient positive and move our variables to the side where that can happen, then we don't have to take care of that extra step. So let's look at these examples, and we'll hopefully by working out these examples you'll see better how we can choose which side to put our variables on. Alright, so here's our first example right here. 5x equals 2x plus 12. Now I do have variables on both sides of the equal sign, so I want to try to get it over to one side. So the first thing I'm going to do is look at the 5x and the 2x. Now if I move the 5x over to the 2x and subtracted by 5x on both sides, then that would give me a negative 3x on this side. So since I don't want a negative coefficient, let's try it again as they recommend here and get rid of the 2x. So to get rid of this 2x right here, I subtract 2x, but I got to do it on both sides. So now I have a 5x minus 2x, and that leaves me with 3x on the left. And then since it went away up here, all I have left is the 12 right here. So then I'm left with 3x equals 12. And hopefully from that point you'll understand what to do from there. I need to get rid of the 3 so I can isolate my x. So I need to divide by 3 on both sides. Those 3's become 1's and leaves me with the x, and 12 divided by 3 is 4. And then I can go back and check my answer. Since I got 4 for x, wherever there is an x, I could plug in a 4 and know that 5 times 4 is 20. And then 2 times 4 is 8, plus 12 is also 20, and that checks out. It should work out. Whatever we get for x, it should work out. This is an equation. They should be equal to each other. All right, next problem. Here's our equation. Negative 6z plus 28 equals 9z minus 2. So here's a couple of steps before we solve. We need to move the z's over on one side and the numbers on the other. So if I subtracted 9z from both sides, I'd get a negative 15z on the left. Don't want to do that. So to get a positive coefficient, I need to get rid of the negative 6z. So I'm going to add 6z on both sides to get rid of that. So those wash away. And then 9z plus 6z on the right gives me 15z, and I got to bring down that minus 2, and it leaves me with 28 over here. Now I've got to get rid of this minus 2. I'm trying to isolate the z, get it by itself. So now I'm going to take care of any adding or subtracting. So I'm going to add 2 to both sides and end up with 15z on the right and 30 on the left. Now I divide by 15 on both sides, and it gives me z equals 2. All right, so we're just adding a step or two to our multiple step equations. We need to get our variables on one side And we're going to decide which side it goes to whenever we have a positive coefficient. All right, so let's do some of these examples down here on the bottom. All right, I've got 9m equals 4m minus 25. Now, if I subtracted 9m from both sides, then I would end up with a negative 5m on the right. I don't want to do that, so I'm going to subtract 4m on both sides. So that leaves me 5m on the left and this negative 25 on the right. Then I'm going to divide by 5. That leaves me with m equals negative 5. Check your answers whenever you see an m. That's a negative 45. That's a negative 20. Negative 45, does that equal negative 45? Well, yes. So I'm good. All right, number 2, 3h minus 7 equals 5h plus 1. So let's get our h's on one side and our numbers on the other. So let's take care of our h's first. Which side would it be best to get a positive coefficient? If I subtracted 5h on both sides, I'd end up with a negative coefficient. So I want to subtract 3h from both sides, and that leaves me with a negative 7 on the left, and then it leaves me with 2h plus 1. Then I got to get rid of that plus 1, so I'm going to subtract 1 from both sides. So I end up with a 2h over here, and I end up with a negative 8. Negative 7 minus 1 gives you a negative 8. So now I need to divide 2h by 2 and a negative 8 by 2. That leaves me with h on the right, which is what I want, and leaves me with a negative 4 on the left. And then plug it in. 3 times a negative 4 is a negative 12, which will give me a negative 19 on the left. A negative 20 plus 1 is a negative 19, and I'm good. All right, so remember this basic lesson is getting our variables on one side, and whenever we want to choose which side to go on, we're going to try to make our coefficient positive. So that'll help you. And then remember, if you have numbers with the coefficient or with the variables, you've got to get rid of those too. So remember, every step we take is towards the goal of isolating our variable to where we get a variable equals another number. All right, let's look on the back. On the back, we see this is really a trick. When we have a whole bunch of fractions like we see in this equation right here, it looks really messy. We always have to get common denominators when we're adding or subtracting, but there is a little trick that they call it clearing the fractions, and I just say it washes out the fractions, and which is always nice. I mean, a lot of our students aren't comfortable with fractions, so if we can wash those out, then it makes them a little bit easier, and I'll show you how we can turn that first equation into this equation, and then we don't have any fractions. All right, so what we need to do first, and let's circle this note right here, actually ending right there. It doesn't need, we don't need the 6, but it says to clear fractions, determine the LCD of all the fractions that we have going on here. We have a 3, a 6, and a 2. Now the least common denominator for 3, 6, and 2 is 6. So what we want to do is multiply all of our fractions and all of our terms, every single term, we multiply by 6. So let me clear this up a little bit. So I'm going to take this t over 3 and multiply by 6. Now, if you need to put 6 over 1 to help you remember about multiplying fractions, go ahead and do that. But I know that I can cross-reduce or cross-cancel. So that 3 becomes 1, the 6 becomes a 2. So I have 1 on the bottom. 1 times 1 is 1. So I'm left with 2t. All right, then I go to the next term. This was a minus sign, so it's going to treat that like a negative. So put that over 1. I'm going to cancel the 6's. So I end up with a negative 5t, which turns into a minus 5t. All right, then my next term, which was 1/2, I'm going to multiply that by 6, put it over 1, do some cross-reducing or cross-canceling, and I end up with 3. And then I have this t right here I need to multiply by 6, so that turns into 6t. And then, oops, here we go. Then I have this negative 6 times 1, or it was the 6 times 1, but it was minus, so that becomes the minus 6. So now I've changed my first equation with all those fractions to a new equation. Now I'll get rid of the colors here. And here's my new equation. Now we just recently learned how to combine like terms. So I see like terms right here. So I can combine my 2t and my minus 5t to a negative 3t. And that stays plus 3. And then this stays. Now I need to get my variables on one side. And to do that, I'm going to add 3 on both sides. So I end up with my 9t minus 6 on the right, and then I'm left with just the 3 on the left. Now I need to get rid of this minus 6, so I'm going to add 6 on both sides. I end up with a 9 on the left and a 9t on the right. Then I'm going to divide by 9 on both sides and end up with t equals 1. So that's a little trick to turn an equation that's filled with fractions and to turn it into an equation with no fractions. But the first thing we need to do is find that LCD of all the fractions, and then just take that LCD and multiply it to every term in our equation. All right, let's do another example. Let's see. Number 3. Let's look at our fractions. We got 4, 2, and 4. So let's figure out what the LCD is. That LCD is going to be 4. So we're going to multiply every term by 4, even on both sides of the equal sign. So if I need to put over 1, that's fine. Do some cross reducing, cross canceling. I end up with 1w. If I do the same thing here, I end up with 2w. If I do the same thing here, I end up with 1. And then 4 times w on the right is just 4w. Now I'm going to combine my like terms. That turns into 3w plus 1 equals 4w. And then I need to get rid of the 1. So let's subtract 1 on both sides. And that gives me 3w on the left, and it gives me 3 on the right. And then I'll divide by 3. And w equals 1. All right, let's do the last one on this page, number 4. Looks like there's no fractions I need to wash out. So let's combine our like terms, our 3m and our minus m on the left. So that'll turn into 2m plus 17. I can combine the 10 and the minus 2, so that becomes 8 minus m. All right, then I need to, let's get our m's on one side. So to get that positive coefficient, I'm going to add the m over here to both sides. That gives me 3m plus 17 equals 8. Then I need to get rid of the 17. That gives me 3m on the left, and 8 minus 17 is going to give me a negative 9. And then I'm going to divide by 3. M equals negative 3. And then I'm going to go back and check. 3 times negative 3 plus 17 minus negative 3. And 10 minus negative 3 minus 2. All right. 3 times negative 3 is a negative 9 plus 17. And then minus a negative turns into a plus 3. So if we're subtracting a negative, we're really going to add now. We keep change. And then 10 minus, let's see, 10 minus a negative 3 is going to end up being 10 plus 3 minus 2. So we've got negative 9 plus 20, and then we've got 13 minus 2. That's going to be 11. 13 minus 2 is 11, and it checks out, and we're all good. All right, so now you've got some good examples to follow. The homework assignment is 11-3 practice, odds only, and feel free to email me if you have any questions, but hopefully you have some good examples here to help you. Follow the examples, make sure you show every step, and make sure you're taking care of every step it takes to isolate the variable. That's our goal. And then check it if you've got some time. but you don't have to check it. It just would be nice to make sure that the answer that you got is correct. And you can do that really quick. You don't have to do this whole big thing over here. You can just plug in the numbers and see if you get it right. All right.